Hello. In today's session, we will learn how to write down the logarithm of how to find out the logarithm of a number by using the logarithm table. We will not discuss the theory of the logarithms. We will simply learn how to use the logarithm table to determine the logarithm of a number and do simple operations like multiplying two numbers or dividing one number with the other. That is all what we are going to do here. Now, before proceeding with the using of the logarithm table, let us see how the logarithm of a number can be written. Remember one thing, the logarithm of every number has got two parts. The first part is called a characteristic and the second part is called a mandisa. So logarithm of every number has two parts. One part is called, the first part is called characteristic and the second part is called mandisa. Now the next point is, in order to determine the characteristic of a number, you don't require the logarithm table. Just by looking at the number, you can write the characteristic. But to determine the mandisa part, we seek the help of the logarithm table. So the logarithm table is used only for determining the mandisa of a number, whose characteristic we can write just by looking at the number. So we will first learn how to write the characteristic of a number. We start with the number, say 1, 2, 3, 4. This is a non-decimal number. We will first deal with the non-decimal numbers. So here you have a 4-digit number. I want to write the characteristic. Remember, you are not going to use the logarithm table. In order to determine the characteristic, you don't require the logarithm table. So just look at this number, 1, 2, 3, 4. How many digits are there? There are only 4. 1, 2, 3, 4. So you have 4 digits in the number 1, 2, 3, 4. All you have to do is to subtract 1 from the total number of digits. So here you have 4 digits. Subtract 1 from it, you will get 3. So the characteristic part of this number's logarithm is 3. Clear? Just count the number of digits. Subtract 1. That is your characteristic. Now suppose you have 10,000. How many digits are there? 1, 2, 3, 4, 5. What should I do? Subtract 1. So what will I get? 5 minus 1, 4. Just do it. Subtract 1 from the total number of digits and write it as your characteristic. Write it as your characteristic. Clear? Okay. So sir, what will happen if the number is 1? Just subtract. 1, you have only 1 digit. Subtract 1, 0. So the characteristic will be 0. Whatever is the number of digits, just subtract 1. Whatever you get, that will be your characteristic. Clear? Okay. This is regarding non-decimal numbers. Now, let us look at a number which has a decimal part 2. See, I am writing a number 0.1234. This is a decimal number. So far what we were doing is, we were counting the number of digits in the number and subtract 1 from that. And we were dealing only with non-decimal numbers. Now we have a decimal number. So what we have to do is, suppose this was 1.234. Say, we start with the 1, 2, 3, 4 again. What is the characteristic? 4 minus 1, 3. 123.4. What are the number of characteristics? See, here you have a decimal number. So what you have to do is to subtract from the total number of digits before the decimal point. Subtract 1 from the total number of digits before the decimal. How many digits are there before the decimal? 1, 2, 3. Subtract 1 from that. So you will get 2. Here you have 3. Here you have 2. Now the next number, 12.34. How many digits are there before the decimal? 2. Subtract 1. What will you get? 1. Clear? Now, suppose this is 1.234. How many digits are there before decimal? Only 1. Subtract 1 from it. What will you get? 0. So the characteristic is 0. Okay. Now, we come to a pure decimal number 0.1234. So when I try to subtract something from the number of digits before the decimal, I find that nothing is there before the decimal. No digit is present, no non-zero digit is present before the decimal. So what can I do? All I can do is to write -1 here. Clear? Because here you have nothing, non-zero digit, no non-zero digit is present here for you to subtract. So proceeding like what we have done so far, if I try to subtract something, I should end with the -1. Okay, but we have a small problem. I told you that to determine the Mandisa part, second part of the logarithm of a number, we will use the logarithm double. And the Mandisa of a number is always positive. So we cannot write the characteristic as a negative number. In that case, followed by this characteristic, we will write the Mandisa by using the logarithm double. So if I put a negative sign in front, it may be interpreted as the whole, or we may have to interpret the whole number as a negative number. That is not correct. Clear? Mandisa is always a positive number. If I write the characteristic as -1 and then write the Mandisa after this, the whole number may be considered as a negative number. That is not how it should be. So what should I do? Instead of writing the -1, I will write it as bar1. Meaning that only the characteristic part is negative. Clear? Now suppose this is 0.1234. What will be your characteristic? Simple. Bar 2. 0.001234. What is the characteristic? Bar 3. Clear? Is it clear? You can also write it in another way. 1234. 1.234 into 10 cube. What is the power of 10? 3. What is the characteristic? 3. Simple. Now write this as 1.234 into 10 raised to, sorry. This is 1.234 into 10 raised to 2, correct? So what is the power of 10? 2. What is the characteristic? 2. This one? This is 12.34. 1.234 into 10 raised to 1. What is your power? 1. What is your characteristic? 1. Proceeding like that, you can write the characteristic of every number. Now come here. You look this. What is the, or let us look at this. This one, 0.1234. This is 1.234 into 10 raised to -1. What is the power of 10? -1. What is your characteristic? Bar 1. See? So by expressing this as the power of 10, you can straight away write down the characteristic by looking at the power of 10. Clear? This is how we determine the characteristic of a number. Now let us look at the Mandisa part. In order to look at the Mandisa part, we need the help of the logarithm table. So I have written the logarithm of two numbers here and also the anti-logarithm. So we will do a simple mathematical operation here, and through that I will show you how the logarithm of a number can be determined by using the logarithm table, and how the mathematical operation will give you the desired result. For that, we will multiply two numbers. Let us multiply two numbers, and the numbers are 12.32 and 1.421. So this is your mathematical operation, 1.421. We have to find the logarithm of this. So we are going to multiply 12.32 with 1.421 and find the product by using the logarithm table. I told you that log of m into n is log m plus log n. So this should be logarithm of 12.32 plus logarithm of 1.421. Clear? Log mn is log m plus log n. Now let us look at the logarithm table. I think all of you have the logarithm table. So if you take the logarithm table, open the logarithm table and try to find the logarithm of the first number, which is 12.32, you will find that in the first column of your logarithm table, you will find that there are, in the first column, there are numbers between 10 and 99. In the logarithm table which you carry now, in the first column, you will find that there are numbers from 10 to 99, followed by a row in which 0 to 9, numbers from 0 to 9 are written, and below each digit, below 0, below 1, below 2, etc., you will again find 4-digit numbers. So that is the first part. Now second part, when you look, you will find another column in which mean difference is written. So I will explain what is meant by mean difference. Now you take the logarithm table and search for the logarithm of 12, because that first number is 12.32. So search for the first number, first 2 digits, 12 in the first column. So the first column starts with 10, you go down and you come across 12. Then here, so we have reached at 12. Now the next 2 digits are 3 and 2. So what should we do? At 12, you put your finger, then move it straight. 12, move it straight and reach 3, because the next digit is 3. So look at the value where the 12 and 3 intersect. 12 and 3. You find that the number is 0899. So corresponding to the row 12 and the column 3, we find that the value given is 0899. Now we are left with one more digit, which is 2. And to find that, to use that, you go to the column of mean difference. Move through the same row in which we have been traveling so far. 12, 3, move forward until you reach mean difference, and below 3 in mean difference you look for the number, or below 2 in the mean difference column you look at the number, and below 2 you will find that the number 7 is written. So 12, 3, mean difference 2, this is 7, add them. This is 0.96, 0.0906. Okay. So we have calculated the Mandisa part using the logarithm table. We started with 12, moved ahead, moved along the same row until we reached 3. We found the intersection, value at the intersection, which was 0899. Then we proceeded to the mean difference column and search for the value written below 2, which was 7. Adding the 2, we got 0.0906. Okay. Now, what is the characteristic of the number 12.32? How many non-zero digits are, how many digits are there before the decimal point? 2. So what is our rule for writing down the characteristic? Subtract 1. So you will get the logarithm of this number 12. So logarithm of 12.32 is 1.0906. Clear? So the logarithm of the number 12.32 is 1.0906. Now let us proceed to find the logarithm of 1.421. So before searching for the Mandisa, straight away we will write the characteristic. How many digits are there before the decimal? 1. So what should be the characteristic? 0. So logarithm of 1.421, characteristic is 0. Now we will search for the Mandisa. Similar to what we have done in the previous case. 14, move along the same row, look at the intersecting value below 2, it is 1523. Then proceed to the mean difference column, below 1 you have 3, so add the 2, this is 1526. Put it here, so this is 1526. So we have found out the logarithm of both the 12.32 and 1.421. Now what should we do? Log mn is log m plus log n. Add these two. You will get this as this is 1.2432. So what we have obtained is 1.2432. So we have obtained a number which is 1.2432. Now from this, to get the final result, to get the product, we will search for we will pass on to the next page, which gives the anti-logarithm of numbers. So now we will do a reverse operation. We are going to find the anti-logarithm of this number, 1.2432. See, we are going to get the product of these two numbers by using the anti-logarithm. Now while looking at the anti-logarithm page, you will find that you start with the first row starts with 0.00, first column starts with 0.00 and it goes all the way up to 0.99. Then you have 0 to 9 columns and also a column representing the mean difference, like what we have seen earlier. So here your number starts with the 0.00 and goes all the way up to 0.99. So we have nothing to do with the first part here, the characteristic part. We have to do nothing while finding the anti-logarithm. Let it be there for some time. We will not look at that number which is written in the place of the characteristic. Okay. So now let us see how the anti-logarithm can be found out. Our number is 0.24. This is 0.2432. So take the first two digits, 0.24. Go to the number 0.24 in the first column, 0.24. Then you move straight along the same row like what we have done earlier until you reach 3. So look at the intersecting values, 0.24, 3. It is 1750. So 0.24, 3 intersecting values 1750. Clear? Okay. Now one more digit is left, that is 2. For that we will look at the mean difference column, and 2, for that the intersecting value is 1. So add it to the already obtained value 1750, which is 1751. So now you have found out the anti-logarithm corresponding to 0.2432, which is 1751. We are not finished yet because our characteristic part is remaining as 1. See, this one is very important. So you have to do something with this characteristic part 1. This is the anti-logarithm of this number, which means that if you find the logarithm of this number, you should get this. Clear? This is the anti-logarithm of this is the anti-logarithm of this 1.2432 is the number whose anti-logarithm we have written as 1751. Or else, if you find the logarithm of 1751, you should get 1.2432. And what is the characteristic part? 1. So this number has a characteristic part 1. 1751 has a characteristic 1. So how many digits should be there before the decimal? 2. Put the decimal here. So this is your final result, 17.51. So when you multiply these two, you have obtained 17.51. Clear? So the product of those two numbers, we have obtained 17.51. The characteristic must be, or this, there must be 2 digits before the decimal. Why? When you find the logarithm of this, you get a number who has 1 as characteristic. If the 1 is a characteristic here, there should be 2 digits before the decimal in the original number. This is the anti-logarithm of 0.2432, or 17.51 must have a logarithm which is 1.2432. Clear? Okay.